Hi there. After validation of the measurement model analysis, now we will move to structural model validity and hypothesis testing. So the structural model, this is the second model estimated in structural equation modeling. Before that, we have estimated the first model, that was measurement model. So it represents the theory specifying the relationship among the construct. That means the inner model in PLS-SEM. The relationship between the construct themselves is the structural model or the hypothetical relationship that we have drawn. Before that, we estimated the measurement model. That means the measurement items and their associated construct. The relationship between items and their associated construct was measured in measurement model analysis, and in the structural model analysis we are interested to see whether the effects of the exogenous constructs are significant on their endogenous construct or not. That means the hypothetical relationship. So whether the constructs are interrelated to each other or not. Straight arrow are show dependence relationship. That means arrow is pointing towards the endogenous construct. That means they are exogenous, then this is endogenous, as the arrow pointing from the exogenous to the endogenous. And it tests the hypothesis proposed in the literature review. So you have to develop your model in a way that helps you to analyze the hypothesis, test the hypothesis that were proposed in the literature review part. So there's all of the criteria that we in general use in order to estimate our structural model validity. So first of all, the multicollinearity among the exogenous construct. That means the VIF should be less than 5, that we already have determined in SPSS. If you do not calculate those in SPSS, you can use Smart PLS. Smart PLS will also give you the results. Then size and significance of the path coefficients. That means the hypothesis testing, in hypothesis testing part, we see the path coefficient, the beta value. So the beta value, the size is positive or negative, then it is significant, the p value and t value is significant or not. We assess the p value and t value here. Then we see the explanatory power of the exogenous construct by r square, or which is also called coefficient of determination. Then we also see the effect size by f square. Then we also see the predictive power of the model. That means the intention, that we are trying to predict the intention of the people to use ChatGPT. So we want to see which factor has got the most predictive power, or our model is predictive, has got the predictive relevance or not. Thereby we see the PLS predict procedure, or which is also called Q square predict. So first of all, the multicollinearity assessment that I already have done in SPSS, but if you want to do it in Smart PLS, you can do it. So as multicollinearity basically assess the correlation, high correlation among the independent or exogenous construct. So the BF value should be less than 5, say all the BF value less than 5. That's why the multicollinearity issue is not a problem in our case. So multicollinearity is the extent to which two or more construct in a structural model are correlated with each other. So and VIF, it is a statistic used to evaluate the severity of the collinearity among the indicators in a formative measurement model. That means, in case of formative, we also see that means the arrow drawn from the 3 construct to 1 construct. At the time you need to determine the multicollinearity among the 3 endogenous construct, and it should be less than 5, the value of VIF. Then for determining the size and significance of the path coefficient, you need to use the procedure of bootstrapping in Smart PLS. As we already have said that in PLS-SEM, it do not give you the restriction of normality of the data, because it applies the bootstrapping procedure. That means it is a resampling technique that randomly draw a large number of subsample from the original data with replacement, without applying the distributional assumptions. That means estimate the models for each subsample. It indicates that the 100 sample we are using, the bootstrapping procedure will produce some subsample with replacement from our original sample. That's why the normality of the data, that is the requirement, it is not required in PLS-SEM or in Smart PLS. So bootstrapping is done and after that you will get a bootstrap confidence interval. It will give you, say for example, the bootstrapping result is presented here. We will see the actual demonstration in the Smart PLS as well. So this is the result of the bootstrapping. So here is the p-value are given, the t-value are given, the or beta value are given, and the graph is like that. They are the t-value, and these are the, in the bracket, these are the p-values, and these are the path coefficients, and this is the t-value of the influence of latent variable on their individual items, and this is the actual correlation that, or actual influence that we are interested to see. So bootstrap confidence interval will give you a particular confidence upper level, lower level confidence interval for each of the path coefficient. It is the estimated range of the value that is likely to include an unknown population parameter. When 0 does not fall in the confidence interval, an estimated parameter is considered to be significantly different from 0 for prescribed probability of error. We'll explain it in practically and see it in the Smart PLS. That means the path coefficient that already determined by the software, whether the coefficient is significant or not, it can be determined by seeing the confidence interval. And the critical t-value, these are the t-value. I did not it is not able to show the critical t-value here because we have already used two value here, path coefficient and p-value. If you want to show t-value here, you can also select it from the software. So t-value is basically the test statistic that we compare with the critical value. So normally critical value is 1.96. If your t-value is higher than 1.96 at a particular significance level, say for example 5% significance level, if your calculated t-value is higher than 1.96, you can reject your null hypothesis. That means there is no influence of this independent variable on dependent variable. That means there is a significant influence. So we determine the t-value after, and we compare it with the 1.96, and your p-value will be less than 0.05. At that time your result will be significant. And path coefficient is the estimate of the path relationships in the structural model. This is the path coefficient 0.565. This it shows that it is positive. That means perceived usefulness positively influence intention to use ChatGPT, and the size of the influence is 0.556. That means if perceived usefulness increases by 1 unit, intention will be increased by 0.556, which correspond to the standardized beta in regression analysis. You also get the standardized beta in regression analysis, and in case of Smart PLS it is called path coefficient. I think the theoretical discussion will help you to understand the practical analysis in the software.